Good
Good
morning.
morning, sir.
Good morning. We were discussing
Good morning,
something related to graphs. We have learned how to make a pie chart. In today's session, we shall take up line graph. There is a small difference between line graph and a linear graph. A line graph is having many line segments. A linear graph will be a continuous one. You will find the difference when I deal with linear graph. Now coming to line graph. Line graph will display the data. It changes continuously over time period. Here there's a line graph. You can see the content of the graph. It is having x-axis and y-axis. On the x-axis, here time is mentioned. On the y-axis, the temperatures are mentioned. So this point of intersection can be referred to as 6 comma 37. So with respect to x value 6, the value of y is 37. What is the scale in this graph? On x-axis, am I audible?
Yes, sir.
Yes, sir.
Yes, what is the scale? It's difficult to tell.
Yes, sir.
On y-axis, at least.
Sir,
So
two, sir.
y-axis is 2.
Sir, on
Yes.
the x-axis, scale is 4.
X-axis 4, sir. Y-axis 2, sir.
X-axis is 4, y-axis is 2.
Yes, sir.
Yes, sir.
So here, after 30, next one is 31, next one is 32. It's only one, no? They have not mentioned all the points there. Let us not worry about that.
Sir, then x-axis is equal to 2.
X-axis is 2. From year to year, this becomes 8, next is 10, isn't it? Yeah, now it is making little sense. So not to worry about the scale. Just observe this. This is also a line graph. Here there are two lines. One is dotted one is a complete line. This dotted one gives the scores of batsman A. This complete line gives the scores of batsman B. With respect to the number of matches, we can compare both the scores. Can we make a table from this given graph? Here, let me mention the matches. This is for batsman A, batsman B. For the first match, one match, batsman A's score is 20.
20 runs.
Batsman B, his
60
score is
runs.
60 runs. For second match,
Batsman A 115.
115.
115. For batsman B,
40 runs.
40
40
runs.
runs.
For the third match,
0.
0.
60.
And
50.
this particular number is 50.
50.
For batsman, for fourth match,
60,
both
sir.
of them
60.
they have scored the
Both of
same
them are
runs,
60.
60 runs. For the fifth match,
20,
20
and
20 and 45.
45.
45. For the sixth match,
90 and
90.
45.
Yes, sir. 90,
90
45.
and 45. In the seventh match,
Sir, 35 and 100. Sir,
100.
in the eighth match,
sir, 75 and 60.
in the ninth match,
0 and
50.
50, sir.
0 and 50.
for the 10th match,
45 and 55, sir.
55.
so just by looking at the graph, we can come to know their scores with respect to the matches. In which match their scores were same?
Fourth match, sir.
In the fourth match. In which two matches batsmen's B scores are same? Batsman B score is same in
Sir, 1, 4.
5
5
and
and
6.
6.
5 and
5
6.
and 6,
5
sir.
and 6, their scores are same. In which match batsman's A score is maximum?
Second match.
Six,
150.
Match, sir.
150.
115.
115 in the second match. When I asked in which matches their scores were same, you said in match 4 the scores were 60 each. Not only that, there is one more match their scores are same, which is that in the
Sir, 3 and 9, sir.
3 and 9. No. That was a wrong question. Batsman's A score is same in these places. 3 and 9 and 1 and 5. Their scores are same. For batsman B, his score is same in these two matches.
5 and 6.
2.
5 and 6. So we can interpret some information from line graph also, as we were interpreting in
Sir,
Sir,
histogram.
3 and
4
3
and
and 9 also.
For B, 1, 4, 8, sir. Same. 60
For
runs.
B148.
Yes,
Correct, sir. You're absolutely correct. 1, 4, and 8.
Sir, 3 and 9 also.
Sir, 3 and 9 also, sir.
Yeah, 3 and 9 also. So we can interpret some information from line graph also, as we were doing it in class 7th and 6th. When they give bar graph or a histogram, we know how to interpret the data. Here, when line graph is given, still we can interpret the data. Just look at this. The given graph describes the distances of a car from a city P at different times when it is traveling from city P to Q, which are 350 kilometer apart. Study the graph and answer the following. What information is given on two axes?
Sir, distance and time.
Distance and time.
On
Distance,
x-axis,
time.
it's a time taken. On y-axis, it's the distance. From where and when the car begin its journey?
From 8 a.m.
From 8 a.m. to 2 p.m., sir. 8 a.m. to 2 p.m., sir.
To 2 p.m. That is the complete journey you are telling. From where and when? For when means at 8 a.m. From where? From,
From city P.
we have to mention this. From city P. Okay. From city P at 8 a.m. the car began its journey. Question 3. How far did the car go in the first hour? In the
50
first
50
hour,
50
kilometers, sir.
kilometers.
50 kilometers,
it
sir.
has
50
traveled 50
kilometers, sir.
kilometers. So it's easy to answer now. Let me write somewhere here. Okay, 50 kilometer. This one from city A, sorry, city P at 8 a.m. How far did the car go during the second hour and the third hour?
Sir,
Second hour
150
100
kilometer
kilometers,
and
sir.
200 kilometers, sir.
Third hour 50 kilometer.
No, sir.
Second
One.
hour is from 9 to 10. From 9
The third
to
hour is
10.
150 kilometer.
150
From 9 to
kilometers, sir.
10, we have to find this difference, isn't it?
Sir,
100
third
kilometer.
hour is 50 kilometers, sir. 100 kilometers.
This is 1 hour, first hour. This is second hour.
Yes, sir.
This is third hour. For second hour, from here to here,
100
means
kilometer.
from 50 to 150. The difference is 100. So
Yes, sir.
for the second hour, it has traveled 100 kilometers. For the third hour, it starts from here
50
and ends
kilometer.
here.
50
So
kilometer.
from here to here, it will be 50 kilometer distance, isn't it? So 50 kilometer respectively. Was the speed same during the first 3 hours? How did
No,
you know
sir.
that?
No, sir.
No,
No,
sir.
sir.
So it should be equal, sir. The
They are not the
distance
same.
traveled should be equal, sir.
Yes, sir.
Why?
The
Why,
speed is not
Shobhan? Why distance traveled should be equal?
So that's why the same during the first 3 hours, the same speed should be calculated, sir. So distance should be same, sir. It is only 1 hour is shown in the graph, sir.
If speed has to be same, when time is same, the distance also must be same.
And the line should be straight, sir. First, if speed is same, then line will be same during 3 hours. Means straight.
And what is it called as? Did you come across this word in physics?
Yes, sir.
Uniform
Yes,
speed.
sir.
Yes, sir. Yes, sir.
Yes, sir.
Yes, sir.
Yes, sir.
If
Speed
the
is equal
distance covered
to distance by time.
is same in each interval of time, it is called as uniform speed. Here it is not a uniform speed because the distances are different in the time duration. Time interval is 1 hour here. 1 hour is the time duration. From 8 to 9 it is 1 hour. From 9 to 10 also it is 1 hour. From 10 to 11 also it's 1 hour. Each time we are taking 1 hour as the interval, but the distances covered are different. Since it is not a uniform speed, we can say that the speed in the first 3 hours are not same. Did the car stop for some duration at any place? Justify your answer.
Yes, sir. 11 a.m. to 12 noon, sir.
11 a.m.
11 a.m. to 12 noon.
What is the
For one.
distance traveled?
No distance is traveled.
No distance, sir.
So it is 0 kilometers.
Yes, sir.
No distance is traveled from 11 to 12. Very good. From 11 a.m. to 12 a.m. No distance has been covered. When did the car reach City Q?
2 p.m.,
2
sir.
p.m., sir.
2
2
p.m.
p.m.
2
After
p.m.
reaching 350 kilometers. 2
Yeah,
p.m.
2 p.m. is the time. Let us see the exercise question. The following graph shows the temperature of a patient in a hospital recorded every hour. What is the patient's temperature at 1 p.m.? When was patient's temperature 38.5 degrees Celsius? The patient's temperature was the same 2 times during the period given. What were the 2 times? What does temperature at 1:30 p.m.? What was the temperature at 1:30 p.m.? How did you arrive at your answer? During which period did patient's temperature showed an upward trend? It's very clear from the graph that
Yes, sir.
temperature
10,
is varying every hour,
10 to
but at
11.
some place it remains same from 1 to 2 p.m. Let's
Yes.
discuss the answer now. What was patient's temperature at 1 p.m.?
36.5, sir.
36.5.
36.5 degrees,
1
sir.
p.m. is this.
Degrees Celsius, sir.
Since they have given
36.5 degrees Celsius.
34, this is 35, so this has to be 34.5. So each one division is 0.5 units. So this has to be 36.5 degrees Celsius. When was the patient's temperature? 38.5 degrees Celsius. 38.5.
12 p.m., sir.
12 p.m.
12 p.m.
Is here.
Sir.
So we can draw a horizontal line with respect to 38.5 from their vertical line, so that easily we will come to know that it is 12 noon. So it is 12 noon. The patient's temperature was the same 2 times during the given period. What were these 2 times? They
Sir,
were
1 and 2,
1
sir.
p.m.
2 p.m. and
1 to 2 p.m.
1 p.m. and 2 p.m. What was the temperature at 1:30 p.m.?
36.5,
Sir,
sir.
36.5 degrees Celsius. 36.5 degrees Celsius.
Because
So it was same during 1 p.m. and 2 p.m. sir. So the middle will be also same, sir.
correct. Now you can see there is a straight line. There is no variation here. So the temperature has to be same throughout. It is 36.5 degrees Celsius. During which periods did patient's temperature showed an upward
So
trend?
10 to 11 a.m.
11 a.m. sir.
10 a.m. to 11 a.m.
From, can I say this, 9 a.m.
Then 9 to 11.
9 a.m. to 11 a.m.
11 a.m., sir.
Yes, sir.
Because there is
Sir, it
increase,
start increasing from 9,
further
sir.
increase is there. It starts
Sir,
Yes,
and
sir.
2
increasing
to 3 also, sir.
here, and further there is increase. Then there is a decrease. Afterwards, at the end, 2 to 3 also there is an increase.
Yes, sir.
So should we split the answer and write 9 a.m. to 10 a.m., 11 a.m. to, how much is the time? So no, 10 a.m. to 11 a.m. Then
Sir, 10 a.m. to 11 a.m.
3.
No need of splitting, sir, because
Yes,
both
sir.
sides are upward.
Yes, sir.
11 a.m.
So they've just asked upward trend, isn't it? So this is enough. 9 a.m. to 11 a.m.
Yes, sir.
Yes, sir.
9 a.m. to 11 a.m.
Question 2. The following line graph shows the yearly scales figures for a manufacturing company. What were the scales in 2002 and 2006? What were the scales in 2003 and 2005? Compute the difference between the sales in 2002 and 2006. In which year was the greatest difference between the sales as compared to the previous year? Here, years are mentioned on the x-axis and the sales in crores is mentioned on y-axis. We have to see the scale in 2002 and 2006.
In 2002, 4 crores, sir.
4, sir, and
And
2006,
2006,
it
8
is
Crore.
crores.
8, sir.
7 crores, sir.
8
2003.
in
Yes, sir. Yes, sir. Yes, sir.
6 there are 8.
In 2002,
2002, 4 crore sales, sir.
Yes, sir.
4
4
crores.
crores sales and
2006, 8
And in
crores.
2006, 8 crore
8
sales.
crores.
3 are 8.
What about
Difference
2005?
is 4 crore.
6.5, sir.
7, sir.
7
6.
crores.
7 crores. In 2005,
10 crores.
10
10
10,
crores.
sir.
crores.
10.
Here, let's see 2002 and 2006. In 2002, 4
Difference,
crores. And
4
in
crores,
the
sir.
8 crore
2006,
minus
it
4
is
crore.
8
4
minus
8
crores, sir.
minus
4.
4 is equal
4
to
crores, sir.
4,
4
sir.
crores.
4 crore.
In which year was the greatest difference between the scales as compared to the previous year?
2005, sir.
2005
2005 and
to
Yes,
2004,
Look
sir.
sir.
at the length of the line segment here. It's a maximum here. Isn't
Yes,
it?
sir.
Yes,
Yes,
sir.
sir.
2005, sir.
4 and 2005.
2004
10,
to 2000,
2005.
4 crores, sir.
it is
yes, sir.
4 crores. In the
Yes,
Yes,
sir.
sir.
previous year, it's just 7 minus 6.
7 minus 4.
7
4
minus
minus.
4.
4, sir.
Yes,
Only
sir. 3 crore.
7 minus
4.
7 minus, no, this is 7. 7 minus
8
6. 1
minus
crore.
4.
No. Here
Yes,
the
sir.
difference is 1 crore. Here we are getting 4 crores.
No, sir, we have to find difference from the previous one.
Yes,
Previous
sir.
year,
Furious.
from 2004 2003.
Sir, 6
So
crore
it should
minus
write
7
minus
crore.
1 CR,
That will
sir.
be minus 1 crore.
So we are taking difference like this from smaller to larger. So there's a loss. There's a decrease also,
Yes.
isn't it? Minus 1.
Yes.
Yes, sir.
For an experiment in botany, two different plants, plant A and plant B, were grown under similar laboratory conditions. Their heights were measured at the end of each week for 3 weeks. The results are as shown in the graph. So week are mentioned on the x-axis, height of the plants are mentioned on y-axis. How high was plant A after 2 weeks?
7 centimeters, sir.
7 centimeters.
From the graph, when it is difficult to see,
7 centimeters.
7 centimeter.
Yes,
Yes,
sir.
sir.
Yeah, this is 7 centimeter. For the third week,
9 centimeters,
9
sir.
centimeters, sir.
plant A is this.
Yes, sir. 9
So
centimeters.
it's 9 centimeter. For plant B on second week, it's the same 7
7
centimeter.
centimeters.
Yes, sir. 7 centimeter.
For the third week, it is
10
much
centimeter.
more.
10 centimeter.
10 centimeter. How much did plant A grow during the third week?
Sir, 2 centimeter.
Why?
So we should calculate till second week and find total of third week, sir, and minus third week from second week, sir.
Growth and second week growth.
Height of plant in third week minus height of
Second
plant
week.
in second week. What is the
Yes,
height of plant in third week? It is 9
7
centimeter.
centimeters.
Plant A, yeah, plant A. It's 9 centimeter
9 centimeters, sir.
minus height of the plant in the second week.
7.
7. So the difference is
2
2
centimeters.
centimeter.
for plant B, it is 3
Sir,
centimeter.
10 minus
Centimeters, sir.
7. 3 centimeter.
Okay. How much did plant B grow from the end of second week to the end of third week? It's the same question again.
Yes,
Yes,
sir.
sir.
We should do same
3
calculation, sir.
centimeter.
10 centimeter
From
minus 7
7 to 10.
centimeters is equal to 3 centimeters, sir.
Correct. During which week did plant A grow most?
Third week, sir.
Third week, sir.
Yes, sir.
Is it not second
Third
week?
week, sir.
First to second week, sir.
Is
Third
it
week, sir.
not first week? From
Sir,
0
in
to
between first and
Sir,
second
the
week, sir.
increase of plant from first to second week is highest.
here there is 2 centimeter. Here it is 7 centimeter. 2 minus 7 minus 2 is 5 centimeter.
5
So
5
there is a
centimeters.
centimeter.
5 centimeter increase. From here to here, only 2 centimeter
2
increase.
centimeters.
So the maximum is found here. During which week?
Second week.
Second
From
week.
first to second.
End of first week to
End of second week.
second week. During which week did plant B grow least?
Again,
First
end of
week,
first
sir.
week, end of
First week.
second week.
फर्स्ट वीक में कितना है डिफरेंस
1
For
centimeter.
Only
it is just
1
1
1
centimeter, sir.
Let me change this color. This is 1 centimeter for plant B. From here to here, if you observe, 7 minus
6
1,
centimeter.
6
6
centimeter
6
maximum.
centimeter.
From here to here, if you observe, it is
3
3
centimeter.
centimeter. So the least is
1
starting
centimeter.
1 centimeter in the first
first
week.
week. Were the two plants of same height during any week shown here?
Yes, sir. Second week.
Second week. End of second week.
So let's be specific. End of second week.
Yes, sir. The both plants line meets at second week.
This is the point of intersection of both the lines. Question 4. The following graph shows the temperature forecast and the actual temperature for each day of the week. On which days was the forecast temperature same as the actual temperature? Here, forecast temperature is being given in a dotted line. Actual temperature is in an actual line.
Sir, on Tuesday, Friday,
Tuesday, Friday, and
Tuesday and
Sunday.
Friday, and
Tuesday,
on
Friday,
Sunday.
and Sunday.
Tuesday, Sunday, sir.
On Friday
Tuesday, Friday,
And
Sunday.
on Sunday. So three different days. Tuesday, Friday, Sunday. What was the maximum forecast temperature during the week? Maximum.
Sunday, sir.
Sir,
Sunday, sir.
Sunday.
yes, sir.
Sunday.
Forecast. It is here.
Sunday.
35 degrees Celsius. Correct?
Yes,
Yes,
sir.
sir.
35 degree.
What was the minimum actual temperature during the week? Actual. Minimum actual.
Thursday and Friday.
Sir, 15 degrees Celsius on Monday.
15 degrees Celsius, Friday.
Forecast.
Yes, sir. Monday.
Actual we have to see.
Friday and Tuesday, sir. Tuesday and Friday.
It is these two.
Tuesday, Friday,
But the temperature is 15 degrees
15
Celsius.
degrees Celsius.
and Monday.
15 degrees
15 degrees
Celsius.
Celsius is actual temperature.
On which day did actual temperature differ the most from the forecast temperature?
Tuesday.
Maximum
Tuesday, sir.
difference we have to find.
Thursday, sir.
Tuesday. Sir, Tuesday.
Thursday,
Wednesday and Thursday.
If you look
Thursday
at the
only, sir.
difference here,
Thursday, sir.
difference
Thursday
is
only, sir.
how
1
much?
degree Celsius.
Thursday.
So how much is the difference here? 15 and this one is how much?
2.5.
So 2.5. So 17.5 minus
Yes, sir.
15. So 2.5 degrees Celsius. Here the difference is 0 degrees Celsius. Here the difference is
5.
30 minus 25, 5 degrees Celsius. Here the difference,
See,
much?
7.5, sir.
22.5 and this one is 15. So 7.5 degrees Celsius. Here the difference is 0 degrees Celsius. In this case, the
5.
difference is
5.
this is 30 minus 25, 5 degrees Celsius. In this, 0 degrees Celsius.
On
On which
Tuesday,
day?
sir, 7.5 degrees Celsius.
On
Thursday,
Thursday.
sir.
Thursday.
On Thursday, the difference is maximum. Understood?
Yes, sir.
Yes, sir.
Use the tables below to draw linear graphs. The number of days of a hillside city received snowfall in different years. So, years you will mention on x-axis and days you will mention on y-axis. But in the second question, sub-question, this is related to double line graph.
Yes, sir. Men and women, sir.
So you can consider a dotted line for men and complete line for women, and you can try this.
Sir,
Very importantly, how to choose the scale here
Shall I tell, sir?
11.9, 12.8.
Sir,
Hmm.
we can every day we can calculate for every millimeter, sir. Like we can click a point and from we can start it from 11, sir. 11.1, 11.2, 11.3 in this manner, sir.
You will make a kink now.
Yes, sir.
So here somewhere kink, and it is
Starting from
you want
11.1
to
to
take from
12.
11 now. 11 to 12, 11 to 12, 12 to 13,
Yes, sir.
13 to 14. You'll get
Yes,
a
sir.
small graph. 11.3, 11.9, they're very close. If you want to increase the length of the graph, then what to do?
Sir, 11.11, 11.5, 12, 12.5. 11, 11.5.
We should put a that line after 14.
Yes, sir.
If you are taking
11,
11,
11.
11.5 as the next one, between them
Yes,
there are
sir.
10 lines.
Yes, sir.
So what will be each line? This will be 0.5 divided by 10, 0.05. So after 11, the
Yes, sir.
next line will be 11.05, next will be 12, 12.05, 13, 13.05, 14, like that. Understood?
Yes, sir.
Yes, sir.
Will you try this?
Yes, sir.
Yes,
Yes,
sir.
sir.
Sir, here I have a question, sir.
Yes.
Sir, can we represent this graph in negative numbers using x dash and y dash?
Since the numbers given here are all positive, so we need not represent on negative x-axis and negative y-axis. We have to consider only the positive.
Yes, sir.
Okay, sir.
You will come to know when negative numbers are there.
Yes.
Question 6. A courier person cycles from a town to a neighboring suburban area to deliver a parcel to a merchant. His distance from the
Time and
town
reduce
at
distance.
different
What
times
is
is
the scale
shown.
taken for the time axis?
What is the
Time
scale
axis
taken on
will
the
be 1.
time axis?
Sir, 1 a.m.
1 a.m.
So 60 minutes, sir. 1
60
hour.
minutes
Sir,
or
1
1 hour.
a.m. Sir. 1 a.m. or 1
1 hour.
hour. 1 hour, sir.
Not, sir.
No, sir. 25 minutes.
25 minutes, sir.
1 hour, sir.
Minutes, sir.
1 hour.
15,
1
sir.
hour, sir.
Sir,
1
we have
hour.
to
So 25
consider
minutes.
for one block,
15,
na,
sir.
sir.
15 minutes.
15 minutes will happen.
It's like this. Let me tell. This is 8:15. This point
8:30.
is 8:30.
8:30,
This
8:45,
is
9.
8:45.
9.
This is 9. Correct? Huh?
Yes,
Yes,
sir.
sir.
So what does it mean? On x-axis,
15
1
minutes.
centimeter is considered to be
15
15
minutes.
minutes. So first question answered. How much time did the person take for the travel? Yes,
3.5.
travel
11.
from here.
3 hours,
Sir,
It
3 hours,
reached
30
here.
minutes.
3 hours, 30 minutes.
When we drop down
3 hours, 30
this,
minutes. 3.5 hours.
this is
3.5.
11:30 from 8 o'clock. So
Yes,
3
sir.
hours 30 minutes. 3 hours 30 minutes. How far is the place of the merchant from the town?
22
22
kilometers, sir.
22
kilometers.
kilometers, sir.
22 kilometers.
This is the town which is considered to be 0 kilometer place, 0 to 22. 22 kilometer.
Yes,
Yes,
sir.
sir.
Did the person stop on his way?
Yes,
Yes,
sir.
sir.
Yes,
Yes,
sir.
sir.
10 a.m.
10 to 10:30.
10:30, sir.
10 to
10
10
to
10:30.
a.m.
10:30.
to 10:30 a.m. Correct. From 10 a.m. to
10:30
a.m. During which period did he ride fastest?
Sir,
Sir, from 8 to 9.
8 to
From
9.
8 to 9.
8 to 9.
Is it?
Yes, sir.
Yes.
Yes, sir.
Is
Yes,
it
sir.
not from 10:30 to 11:30? Is it not from
No,
that?
sir, it will come 6
No, sir.
kilometers.
No, sir.
During the first hour.
Sir, it is only 6 kilometers per hour, sir. In 8 to 9, it is 10
10
kilometers per
kilometers
hour.
per hour.
So when we calculate the speed, it comes out to be 10 kilometer per hour here.
6
In
kilometers per
this
hour.
case, it will be 22 minus 16, 6 kilometer per hour. So the speed is maximum here from
Yes, sir.
8 a.m.
8 to 9.
to 9 a.m.
In Arthana,
Can there be a time temperature graph as follows? Justify your answer.
Sir, D can't. Sir, C can't be an time temperature graph.
Third one cannot be.
First
Yes.
one can be,
Sir,
sir.
first one.
First
First one
one can be, sir.
first
Other
one,
than
Yes, sir.
everything can be, sir.
first one
It
can be,
can
sir.
be this. Second can be this.
No, sir.
No,
No,
sir.
sir.
No,
No, sir.
It can be,
It should
sir.
start from 0.
temperature can decrease no, from particular
Yes,
temperature
sir.
to suppose you boil water and keep it
Yes,
for
sir.
cooling.
Yes,
It
sir.
cools down after some time.
Yes, sir.
Yes.
Yes, sir.
So this particular case, suddenly, all of a sudden, the temperature may not increase
Yes, sir.
Sir, no. Time is not in motion.
Third cannot be, sir, because time cannot stop.
because time cannot stop. Huh?
Yes, sir.
Yes, sir.
What about fourth one?
The temperature cannot be equal at every time, sir. It may differ, sir.
Yes, sir.
Temperature may differ.
No, sir, it can be, sir.
Sir,
Temperature
it can be.
Can be,
Air
sir.
conditioned
It
room,
can
sir.
be.
it
It
can be,
can
sir.
be, sir.
It can be, sir.
How to justify this answer?
Sir, in an air conditioned room, sir.
Hmm.
The temperature of ice cubes.
Hmm.
Sir, temperature of ice cube in refrigerator.
Yes, sir.
Temperature of ice cube in refrigerator.
For a certain time, sir.
Will it not vary?
Oh, sir. Ice cube will be at 0 degree at every time, sir.
Actually, there is a concept called as a anomalous behavior of water. According to science, anomalous behavior of water is at minus 4 degrees Celsius, the ice starts expanding. So temperature is below 0 degrees Celsius also. Hmm.
Yes, sir.
How to justify the answer?
Sir, our body temperature is always at 37 degree every time.
Yes, sir.
Necessary, no,
Yes, sir.
it varies.
It may increase if we do some physical activities.
Yes, sir.
Suppose
But sir, if a person is sitting for means not doing anything and simply sitting, it will be same, na, sir.
Sir, for some period.
We have to
Sleeping.
take
Sir.
general, sir.
For some period. Some.
it won't be constant.
Sir, in an air conditioned room, sir. If we keep same temperature for long.
In an air conditioned room.
Sir, a burning coal. Sir, the temperature will be constant for some time.
Yes, sir.
So temperature may remain constant.
Yes, sir.
Suppose I consider time duration. Say for example, this is 10 a.m. to 12 a.m. If this is the difference in the temperature, if there is an object placed at some particular place, the temperature of that object, if I am finding, it can remain constant during this time duration, isn't it?
Yes, sir.
Yes,
Yes,
sir.
sir.
So the possibilities are there. It can be there, but
Sir,
this
like
doesn't happen.
temperature of core.
Sir,
Temperature of core, sir.
temperature of core. You're referring this
Yes, sir.
crust core
Yes, sir,
matter.
it can be
You're referring
Yes,
that
sir.
core.
Yes, sir.
I don't know what is the temperature at core, man. Will it remain
It
constant?
can be
Oh,
constant.
no.
Yes, sir.
So it can be constant.
A simple example is you take any object, the object's temperature at particular time duration, it can remain constant.
Yes, sir.
Temperature of sun.
Yes, sir. In deep freeze, they will be given means for fan it will be there, na sir. We have to keep how much temperature we want. It will be that much only, na sir. For some means time.
The temperature of that refrigerator may be that temperature, but the object inside, any object for instance, it will have a capacity to absorb.
No, sir. The particles inside the refrigerator will be always constant degree temperature of that particle.
But it takes little time for attaining
Temperature
that
of sun.
Yes, sir.
to retain that temperature.
Yes, sir.
So this possibility is there. This third one, there is no chance, isn't it?
Yes, sir.
Yes, sir.
Yes, sir. Yes, sir. It can be.
That it shows that time may stop, sir. This saying
Until
that time will
temperature
stop for a
changes,
period of time.
time will not stop, isn't it?
Yes, sir. Time will not, sir.
Shall we continue this session in the next period with linear graph?
Yes,
Yes,
sir.
sir.
Yes, sir.
Yes, sir.
Because to tell linear graph, I have to mention our mathematician Reen Descartes' name. I have to tell his contributions also. I have to tell you,
Yes, sir.
he is not only a mathematician, he is also a great philosopher. You must have come across a sentence or like I think therefore I am. You have come across this line anywhere?
No, sir.
No,
I
sir.
think,
Yes, sir.
I think,
Therefore, I am.
therefore I am. This is a famous quote by Rene Descartes.
I think therefore I am.
Yes.
If you get time, no, you please find out. There are some
Yes.
videos related to this quote. I think therefore I am.
Yes, sir.
I think therefore I am.
Okay, let's discuss tomorrow. Any doubts?
No, sir.